Alright, welcome back to the math show. Today we're going to be talking about some more geometric transformations, but using matrices to figure those out. So we're down here at modeling motion with matrices. So we did the scalar multiplication up here last time. So it says you can transform shapes by moving them, flipping them, turning them, enlarging them, and shrinking them. If your shapes are graphed on a coordinate plane, you can use matrices to find the coordinates of the new image of your shape. Transformations that you can complete with matrices include, okay, so these are the four that we've talked about already. So translations, rotations, reflections, and dilations. Okay. Draw a line from the term to the correct definition. Okay, so you should all know these by now, but translations are just sliding a shape to a new position, reflections are flipping a shape, turning a shape is rotations, and then enlarging or shrinking is the dilation. And on to the next one over here. So what is a vertex matrix? Well, a vertex matrix is it's a matrix that is created from the coordinates of the vertices of a shape. So we'll talk about that in a second, but we can write that down. So matrix created from the vertices of a shape. Okay, actually we should say the coordinates of the vertices from the, in here you can put in the coordinates of the vertices of a shape. So the x and the y values of the corners basically. So for example, if, let's just say we have a quadrilateral and your vertices are a, -1, 5, B is 3, 4, C 4, 0, and D -2, 1. So those are the four corner points of this shape. To translate that into a matrix, a vertex matrix, we would put the x values on top and the y's on the bottom. So it would look like this. So all the x's would go on top. So -1, 3, 4, -2. And then the corresponding y values would go on the bottom. So -1 goes with 5, 3 goes with 4, 4 goes with 0, -2 goes with 1. Okay, so we have a 2 by 4 matrix here because there's two coordinates, x's and y's, and then 4 different points, 4 different vertices. So this is what a vertex matrix should look like. Okay, and then the translation matrix. So translation matrix is a matrix created to show the movement. So it's when you're doing a translation basically. So it shows the movement in the x and the y direction when you're translating it. So say shows movement in x and y direction. Okay. So for example, if I'm translating that shape, let's just say 2 units to the right and 4 units down. So our transformation notation will look like this: 2 right, down 4. A, B, C, D. The translation matrix would, so our x's are going to go on top just like our vertex matrix, and the y's on bottom. So all the x's are moving +2. So actually these are all going to be the same, 2, 2, 2, 2. And we have the same amount as we had in the previous one. And then -4 is the y's. Okay, so your translation matrix, your x's should always be the same and the y's should always be the same. because all of your x's are changing by a +2 and all the y's are changing by a -4. Okay. next. Okay, so let's go over this example of how to translate a shape using matrices. So I'm going to use the same example we did in the previous page. So I've got my same 4 vertices, and I'm going right 2 and down 4. So the first step is to graph the pre-image, so graphing these A, B, C, and D. So -1, 5 should be right here, about. 3, 4 should be there. 4, 0 is here. And -2, 1 is here. So we have this quadrilateral shape here. Okay, and then translations are not hard, so you can actually just count right 2 and down 4 for each of these, and it would not be difficult. But to do this using matrices, you first need to state the vertex matrix, which is the same as we had before, V, and T, our translation matrix, which is the same as before because it's 2's across the top and -4's on the bottom for x's and y's. And then step 3 is you need to add the 2 together. So we're going to add V, the vertex matrix, plus the translation matrix. Okay, so remember when you add matrices, you have to add the corresponding elements. So all the x's up here are going to be added by 2, since that's all the x's up there. All the y's down here are going to be added by -4. So -1 plus 2 is 1, 3 plus 2 is 5, 4 plus 2 is 6, -2 plus 2 is 0. 5 minus 4 is 1, 4 minus 4 is 0, 0 minus 4, -4, 1 minus 4, -3. Okay, and these are our new coordinates. So these are all your primed coordinates, basically. So this is going to be A prime, B prime, C prime, and D prime. Okay, and then we just need to graph each of these. So the first one is 1, 1. So over 1 up 1. That's A prime. Next one is 5, 0. So over 5 up 0 right there. 6, -4 right here. And then 0, -3 right there. So you can see that our shape remains the same. It's just been slid over 2 and down 4. Because that's how you translate using matrices. Okay, now for reflections and rotations, we're going to talk about 3 specific ones. Reflecting across the x-axis, across the y-axis, and across the line y equals x. That is the diagonal line that goes through all the points like 1, 1, 2, 2, 3, 3, -5, -5, etc. And then rotating 90, 180, and 270 degrees about the origin. So these are all going to be about the origin. Okay, so your first, your reflection matrix across the x-axis is going to be this. And these are all going to be 2 by 2 matrices because there are 2 coordinates, x and y. So the first one is going to be 1, 0 on the top row, 0, -1 on the bottom. Okay, so that's reflecting across the x-axis. The y-axis is very similar. You just switch the negatives. So -1 on the top left, +1 on the bottom right. Okay, and then reflecting over the line y equals x is 0, 1, 1, 0. Okay, and then your rotation matrices, so 90 degrees, these are always counterclockwise, remember. So 0, -1, and then 1, 0, and then rotating 180, -1, 0, 0, -1, and 270, 0, 1, -1, 0. Okay, and these are all around the origin. So we're going to use these matrices to help us reflect and rotate our vertex matrix. Alright, moving on. Alright, so for reflections and rotations, we're going to use this example here with triangle ABC, where A is -1, 2, B is 4, 4, and C is 3, -2. And we're going to reflect across the x-axis first for reflections here. So this first thing you want to do is graph it. So graphing our pre-image, I've got graphed here. We're actually going to use the same one for the rotation as well. So you can go ahead and graph both of those if you want, and we're going to rotate at 90 degrees. Okay, so after you have it graphed, mine's going to disappear because that's what it does. Okay, so after you have it graphed, step 2 is to write the vertex matrix. So this time our vertex matrix is going to be 2 by 3 because we only have 3 vertices. So our vertex matrix first point is -1, 2. And then 4, 4. And then 3, -2. And then locate the reflection matrix that you want to use. So in this one we're reflecting it across the x-axis. So our reflection matrix, I'm going to call it R, is going to be 1, 0, 0, -1. Okay, so now you have your vertex matrix V and your reflection matrix R. We're going to multiply the reflection matrix by the vertex matrix. So this is going to be R times V, and this is not the same thing as V times R. Okay, our matrix multiplication is not commutative, so make sure you do the reflection matrix first, multiplied by the vertex matrix. Okay, so R times V, let's get rid of this, R times V, so we write our R first, so 1, 0, 0, -1, times -1, 2, 4, 4, 3, -2. Okay, and you probably should make sure that you can multiply these. So remember, this one is a 2 by 2. This one is a 2 by 3. So the inside numbers match, and that tells us we can multiply them. And the result is going to be a 2 by 3 matrix. Okay, so I'm going to have to erase this so I have room. Actually, I'll just write it over here. You guys can try to have some space in your box, but I'm going to write mine over here. Don't write it in this box because this is going to be the rotation box, but I'm running out of room. So I'm going to write my 2 by 3 matrix over here. So 2 rows by 3 columns, and it should actually be the same dimensions as your vertex matrix because you have the same amount of vertices after you reflect it. So multiplying, we do 1, 0 times the first column. So 1 times -1 is -1, plus 0 times 2 is 0. So -1 plus 0 is -1. And then we do first row, second column. So 1 times 4 is 4. Plus 0 times 4 is 0, so just 4. And then first row, third column. 1 times 3 is 3. And then the next one's 0, so it's just going to stay 3. Okay, then we go down to the second row. So second row, first column, 0 times -1 is 0, -1 times 2 is -2. So really you can actually kind of ignore the 0, and you're just multiplying the 1 by the bottom row, the -1, because 0 times 4 is 0, -1 times 4 is -4, so we get -4 here. 0 times 3 is 0, -1 times -2 is +2. Okay, so this is our new R times V matrix. So this is your prime matrix. So we have A prime, B prime, and C prime. Okay, and the last step is to graph that. So I'm going to go ahead and graph that down here. I gotta scroll down. So our A prime was -1, -2. So back 1 down 2. Our B prime was 4, -4. Right there. And our C prime was 3, 2. Okay, so you can see that that should be a reflection across the x-axis of our original image. Okay, and now let's go on to the rotations. So you should have had it graphed already, and we're rotating at 90 degrees about the origin. So we're only going to be doing things about the origin for now because otherwise we have to adjust things. So just to keep it simple, we're just rotating about the origin now. So again, we need the same vertex matrix, V, and that was -1, 2, 4, 4, and 3, -2. And then a rotation matrix, I'm going to use a small r for rotation, and we're doing 90 degrees. So that one's going to be our 2 by 2, 0, 0, come on, 0, 1, -1, 0. Okay, and then we multiply to get your rotation matrix, or to get the new matrix, we multiply rotation by vertex, so R times V. Okay, so we get 0, 1, -1, 0, multiplied by negative 1, it's not writing, negative 1, 2, 4, 4, 3, negative 2. And again, same dimensions, so we should get a 2 by 3 resulting matrix. So 1, 2, 3, 1, 2, 3. Okay, so the first one we're going to do first row by all the columns. So first row times first column. 0 times negative 1 is 0. 2 times negative 1 is negative 2, so that goes here. 0 times 4 is 0. Negative 1 times 4 is negative 4. 0 times 3. So now I'm doing first row, third column. 0 times 3 is 0. Negative 1 times negative 2 is positive 2. Now I go to the bottom. So second row multiplied by each column. So second row, first column, 1 times negative 1 is negative 1. 0 times 2 is 0, so it stays negative 1. 1 times 4 is 4. 4 times 0 is 0, so we get 4. 1 times 3 is 3, plus 0 times negative 2 is 0, so 3 plus 0 is 3. Okay, and this is our new prime matrix, so we have A prime, B prime, C prime. And now let's graph it. Okay. And we should see that it is a 90-degree rotation of our original matrix. So our first point is negative 2, negative 1. That was A prime. Second is negative 4. I'm not going to write those yet. What did I say? Negative 2, negative 1. Next one was negative 4, 4. And that's B prime, and then 2, 3. So A prime, B prime, C prime. Okay, and that should be a 90-degree rotation of our original matrix. Okay, and that's how you do rotations. So you just multiply the rotation matrix times the vertex matrix to get your new matrix. And on to the last one. Okay, last thing we're going to do is the dilation. So we're going to do the same triangle ABC. So the same coordinates, negative 1, 2 for A, B is 4, 4, and C is 3, negative 2. And we're going to dilate it by a half. And just like our rotations, our dilations are all going to be centered at the origin. So it's going to be getting larger from the origin or shrinking towards the origin. And again, the first step is to write your vertex matrix. So vertex matrix is actually the same as it's always been. So negative 1, 2, 4, 4, and 3, negative 2. Okay, that's the first step. Next, to do the dilation, we actually don't have a dilation matrix. We just multiply the dilation as your scale factor. We actually just do scalar multiplication. So because your scale factor is 1/2, we're just going to multiply your vertex matrix by 1/2. So multiply the vertex matrix by the scale factor. So because we're dilating it by a half, we do 1/2 times our vertex matrix, which is 1/2 times negative 1, 2, 4, 4, 3, negative 2, and that's going to come out to be, so with scalar multiplication, remember you just distribute the 1/2 into every element on the top and the bottom. So we're going to end up getting negative 1/2, 2 and 3 halves on top, and then 1, 2, and negative 1 on the bottom. So this is our new A prime, B prime, C prime. Then we just graph them. So A prime is negative 1/2, 1. So back 1/2, up 1, so about right there. That's pretty good actually. Okay, 2, 2, right there. And then 3 halves is 1.5, and down 1. So A prime, B prime, C prime. And you can see it is now a much smaller triangle. So our triangle is shrunk in half, well, by a scale factor of half. Okay, and that is transformations using matrices. Alright, so make sure you guys take the quiz, and I'll see y'all later. Peace out.